Hello again. Today we're doing some more with sinusoidal graphs. We're going to review first what we've learned so far in Lesson 1. First off, this letter A, this coefficient in front of the sine or the cosine. This is our amplitude, and it describes for us a vertical stretch. And it's the amplitude. Next, this coefficient in front of the variable. Now this could be a t variable, it could be an x variable, it could be a theta. It could be pretty much anything we want it to be. So b is the number, that's the coefficient in front of that independent variable. And so this b helps us to find the period. So it determines the period. Now the period describes something about the horizontalness of the graph. We can see in the diagram below. The period is the distance that it takes for a graph to repeat. So it has something to do with the horizontalness. A change in period results in a horizontal stretch or compression. And the formula that we use to find the period is for sine and cosine. We take 2 pi and divide it by that number b right there. When we get on to tangent graphs, that formula is going to be different. Next up, this k. K determines for us the midline for our sine or cosine graph. And so it is a shift of up or down, meaning that's a vertical shift. Right. So we have a point which completes 1 revolution every 2 minutes. So this is the amount of time it takes for something to repeat. So we can guess that this is going to have something to do with the period of our graph. It goes around a circle of radius 5. So let's draw that out or sketch that out here. We've got a circle of radius 5. We need to make a graph with height on the vertical axis and time on the horizontal axis. This is going to be time in minutes, because the period is described as every 2 minutes, and the height will be, we don't know what unit height we'll have. It says radius 5. So why don't we go with feet? So we need to do a graph and then say its amplitude, midline, and period. And we're going to assume that the point starts at 5, 0, which means that if this is 5, 0 here where our point starts, then this would be 0, 0, basically the center of a coordinate plane. Alright, so at time 0, we have a height of 0, because height is described by our y variable right there. Now, let's think of where the point is after a quarter turn. A quarter turn, we are up here. So a quarter turn, our point is at 0, 5, because we've got radius 5. So it's at a height of 5. Now how much time does it take to reach that point? We see it completes a revolution every 2 minutes. So a quarter of a turn would be a quarter of 2 minutes. A quarter of 2 minutes is a half minute. So we would go to a half minute here, and we would go up to 5. Next, at a half of a turn, we'd be at the point -5, 0. So after a half of a turn, we're at a height of 0. Half of a turn would be half of 2 minutes, and so we'll be at 0 right there. Then 3/4 of a turn, we're at a height of -5. 3/4 of 2 minutes is 1.5 minutes, and so we are now down at -5 right there, or 1.5. Once we get back to where we started, we'll be at a height of 0, and that would be after 2 minutes. And so we'll go there. And of course, this pattern will repeat. We're going to do our sinusoidal graph. That's close enough. All right, so next we state its amplitude. All right, amplitude, the distance from the midline up to the top and down to the bottom. So here's the midline going through the center. It basically divides our graph in half. Distance up to the top is 5, down to the bottom is 5. So that's our amplitude. Next, the midline. Midline is the line y equals 0. And last, the period. How long it takes the graph to repeat. So it's starting at a time of 0 minutes. It repeats once we're at 2 minutes. So it takes 2 minutes to repeat. Next up, an equation for the function. So we have these 3 facts about the function. Let's go up to this formula. First, we need to decide, is this a sine situation or cosine situation? So I'm going to zoom out a little bit. Hopefully we can see both of these at the same time. Both of our information. Both sets of information. Alright, so I'd say that this is best modeled by a sine graph because we start at the midline, go past the midline, and end at the midline here. So let's use the sine function. Our amplitude is 5, so we would use y equals 5 times the sine of some number times t plus the midline number, which is 0. Alright, so then we ask ourselves, what is this b? Well, 2 pi over b gives us the period. We saw that the period here is 2. So we need to solve for b. First, multiply both sides by b, and then divide both sides by 2 to get this b by itself. So our b is pi, and so that's our equation for the graph.